Alright, now H2, now you've got, don't forget the factorial, so you've got H2 divided by 2 factorial, so it's H2 divided by 2, H2 divided by 2 is the coefficient of the s to the power 2, and that coefficient is -1 plus 2z squared, or 2z squared minus 1. 2? Oh yeah, but you've got this 2 here, so you bring that over, and so you'll get 4z squared minus 2. So that's H2, that's your second Hermite here, H2. Alright, now, so for the third term, again, don't forget your factorial, so you get a 6 under here. So H3 divided by 6, H3 divided by 6 will be, that will be equal to the coefficient of s to the 3. Now s to the 3 is this. So 4/3 z cubed minus 2z will be equal to the third Hermite polynomial, so H3 divided by 6. So just take the 6 over, and you'll end up with 8z squared minus 12z. Okay? Now, similarly for the fourth, for H4, so H4 divided by 4 factorial, again, don't forget factorial. So H4 divided by 24, here's your coefficient for s to the, for s to the 4th. So 2/3 z 4th minus 2z squared. Write that down here, take the 24 over, and so your fourth Hermite polynomial, H4, is 16z to the 4th minus 48z squared. And similarly for the fifth, so H5 divided by 5 factorial, so 120. That term here will be equal to the coefficient of s to the 5th here. Okay. So you just write this here, take the 120 all over, and you end up getting this term. Right? Now these two terms were not in the text, so they're just my own calculations. All right. Now it's a two-part question. Second part, you're to check your answers. So we had six answers. So H0 is 1, H2 is 2z, and so on. H3, H4, H5. Yeah. So we had six answers, and we're asked to check them using a different technique, using here. So you're differentiating multiple times. In fact, up to differentiating 5 times. So it gets a bit tedious. I don't think I did it all, did I? I think I only checked up to H3 because well, it gets a bit tedious. Right. So now we need to check. So now you use this formula. So for H0, wherever this n is, just put 0. So -1 to the 0 is just 1. If you're differentiating 0 times, you're not differentiating at all. So you'll have e to the z squared times e to the minus z squared. The z squareds cancel, and you're just left with 1. So H0 is 1. So that makes sense. Now if I have a double bar here, it's just the separator. So whatever's here is different thought from what's to the left-hand side of this double bar. Okay, so let's check what we got for H1, which was 2z. Let's see if we get 2z again using this method. Okay, so H1. So n here will be 1. So we'll get -1 to the 1. So that's just -1 ez squared. And now we're differentiating once. d/z of e to the minus z squared, which is here. Now I've skipped a line. And a function of a function from calculus, remember? So instead of differentiating e to the minus z squared dz, I'm differentiating this with respect to z squared, and then dz squared dz. Sometimes I say z, sometimes I say z. I've lived in 3 English-speaking countries, and in Britain and Australia they say z for the last letter of the alphabet, and the Americans say z. And I've lived in all 3, so yeah, I mix them up. All right. So, well, what is this? Well, it's just e to the minus e to the minus z squared. So you've got minus e to z squared. That's this, and what's in the brackets is this, which is minus e to the minus z squared, and then this is just 2z, of course. All right. Now these two exponentials cancel, and you got a double minus, so the answer is just 2z. Correct. Right? Yeah, we got the same. So checks. All right. H2. Now from the definition, so you put n as 2 here. So minus 1 squared, ez squared, and then the second differential d2 by dz2 of e to the minus z squared, which is here. Okay. So that's just plus, so you got ez squared, which is here, and then you're differentiating this e to the minus z squared twice with respect to z. So I rewrite dz squared in 2, split it up in these 2 terms. Right? So I just leave this here. Now what is dz by e to the minus z squared? Well, we did it just before, so it's just this. In fact, differentiating e to the minus z squared dz happens quite a few times, so it might pay to memorize that as a stepping stone, because we'll use it quite a few times. Right? So dz of e to the minus z squared is just this. It's minus 2z of e to the minus z squared. And then when you differentiate this, now you've got 2 terms. You're differentiating a product. So from calculus, if you differentiate uv, you get u dv plus v du. You get the 2 terms. So if you differentiate this, so you get that minus 2z, let that be u, and you're differentiating v, let's say. And then that's your u, and then you v, is it? That's your v, and then you differentiate u. So you get the 2. Now, let's see. And then you've got to differentiate this again. Okay, so minus 2z, and then this again is your minus 2z e to the minus z squared. So use it the second time, the third time. And this. Now, well, I've run out of board, so I'll stop there and just continue on immediately in the next session on the next quarter board.